I want to go over the elimination method from yesterday, that one problem that had to do with the elimination method. And then we'll go through today's do it and today's lesson, which are, again, you know, pretty much like what we've been doing each and every single day. Everything the end of last week and through this week is all about simultaneous inequality, simultaneous graphs, simultaneous equations, simultaneous ones with elimination and ones with substitution. Now, this is your classic elimination problem because your A's are over your A's, your B's above your B's, and your numbers above your numbers. Now, I could get rid of either variable, but I would prefer to get rid of the B's because the signs are already opposite. Two people on their quiz made note of the fact that the signs were not opposite, that everything was positive. Now, when that happens, you have two choices. You can subtract, and then that'll get rid of one of the variables as soon as you match them up. The other possibility is that you can multiply one of them by a negative. When you multiply one of them by, let's say, a -2, it will change every sign, so the positive becomes a negative, and it'll work itself out. Okay, so those are your two choices should that become a situation. You just reviewed the quiz with each other, so I tend to think you went over that if you were one of those two people. Okay, so I want to eliminate a variable. I'm going to get rid of the B's because of the opposite signs, which means I need to multiply the top one by 3 and the bottom one by 5. You could choose a bigger number as long as it worked out for both. For instance, you could choose 6 and 10 if you wanted to and match up to 30. Distributing the 3 to the first one, I get 12a minus 15b is -39. Okay? Now, distributing the 5 to the bottom, I get 25a plus 15b is equal to 35. Now, this is a very critical skill. You will have something on your part. The way your Regents works is you get all your part 1s, they're worth 2 points each, it's all or nothing. Then you have like 8 or 9 part 2s that are 2 points, but they're partial credit. You can get 0, 1, or 2 out of those. Then you have, I think it's 4 part 4s that are worth 4 each, and 1 part 3 that's, 4 part 3s that are worth 4 each, and 1 part 4 that's worth 6. I think that's how it works. It might be 6 part 3s. And the bottom line is, one of them will be like this. One of them will be either a graphing simultaneous or an algebra simultaneous. And sometimes it's 2 out of all of those questions at the end that are worth so much points. So that's why this is critical information to know. Okay? All right, so I can fill that out later. Adding them up, because the B's already match and the signs are opposite, I'm going to get 37a, equals, that's very difficult to do, -4. Then I'm going to divide by 37, and I'm going to get a hideous, ugly answer. So a is -4/37. Okay, here's what it is. Now I go on to get b, 5a plus 3b equals 7. Now, in the days before calculators, this would make you cringe, but since we have calculators, it's not so bad. -4/37 plus 3b equals 7. This is going to be -20/37 plus 3b equals 7. Now, all I need to do is add 20/37 to both sides. And it's ugly, I'm with you, but your calculator does the work for you. So this is going to come out to be 7 and 20/37. And now I just need to divide by 3. And off the top of my head, I don't know what that is. 7 and 20/37 divided by 3. Make sure you put parentheses 7 plus parentheses 20 divided by 37 parentheses divided by 3. You should get somewhere in the neighborhood of like 2.5-ish.
Yeah, 93/37.
93/37. Good. And that would work out to be 2 and 19/37 if you convert it to a mixed number. Okay? All right, so it's ugly. I get it. But nothing's guaranteed to work out cleanly in this world. I wanted you to see that if it works out ugly, you just keep going, doing the things you're supposed to do. You don't stop. Okay? Any questions? Okay. Now we go on to today's sheet. Today talks about graph the solution set in the coordinate plane, report your answer by selecting two ordered point and verifying that they make the inequality true. Okay, so let's do the first one here. I have to add 10x to both sides. And I get y is greater than 10x plus 25. So I'm going to make the scale on this. I don't want to fit it in here because I don't have much room. We're going to make each of the scales 5, and then on the vertical and the horizontal will stay 1. So 5, 10, 15, 20, 25, there's where I touch. And then I'm going to go up 10 over 1. So up 10 is really up 2 over 1, up 2 over 1. There, now, is that a broken or a solid line? Broken it is. Hello? Yes. What's up? Okay. Yep. No, I'm the old one. All right. See you. Okay. Now, there's the broken line, and I'm going to shade above, and there's my graph. Now, if I were doing this on a Regents exam, I would be very careful to put 1, 2, 3, 4, so I could see the scale here, and 5, 10, 15, 20 here. But it would make this messy, number 1, and number 2, I don't think I could fit it in a way that would look, that you could read it anyway. All right, next one, -6 is less than or equal to y. And the problem with this guy is that the y is not on the left. We always, always, always want the y on the left. So I'm going to move it around a little. I'm going to put the y here, and I'm going to put the -6 here. But what's the cardinal rule when I move inequalities around? Well, it has to continue to point to the same thing. If it points to the -6 here, it's got to point to the -6 here. Now, what's the slope of this line? 0. There is no slope, which means, if you remember, there's two ways to remember this. One way is to say, well, my y-intercept is -6. 1, 2, 3, 4, 5, 6. And then I could say, well, I'm going up 0 over 1, up 0 over 1, up 0 over 1. If you want, up 0 over 2. It doesn't matter. The bottom line is, this is or equal to, so it's a solid line. There we go. Okay? Now, I'm going to end up shading what? Above or below with this guy? Above or below? Above. So there we go. And the last thing I want you to remember, another way to realize that this is a horizontal line, that's a positive slope, right? What's that? Negative slope. And what number is between the positives and the negatives?
Neutral.
Which is known as? 0. So a 0 slope is a perfectly horizontal line. So either way that you remember it, up 0 over 1, up 0 over 1, or if you just remember, look, positives go up, negatives go down, zeros are flat in between. Are there any other numbers between other than positives, negatives, or zeros that you know about? So therefore, if I have a vertical line, just bringing this up here, there's actually no slope. Because all the numbers are taken for here, so there's no slope for it. Okay, next one. Y is less than or equal to 7.5x plus 15. So I'll go to 15. 1, 2, 3, 4. Oh, I'm sorry, I'll go by 3s. 3, 6, 9, 12, 15. And if I'm going to go down 7.5, that means I'm really going to go down halfway. I'm going to go down 2.5 each time to make it go there. All right, is this a solid or a broken line? Solid. Now, your graph may look slightly different depending on if you used a different scale. That's fine, there's no problem with that. Is this shade above or below? Below. There's my graph. Okay? Now, those are some seriously oddball inequalities, and you'll notice that they're given in the Common Core font. So it's not, I don't think, that they're overly hard. It's just that we had to change the scale a little bit, and we had to be aware of a negative slope. So they're kind of like special cases, all right, that are a little bit different, and you just have to do a few of them, and then you realize, well, they pretty much are just like what we already know. Yes?
On the reasons, will the graph be full? Like, will we be able to see the graph?
Oh, yeah, yeah, the Regents, it'll be a full page of a graph. Yeah, definitely, go ahead.
B, there was the same symbol as C sign, but you shouldn't know in that one below.
Yeah, but the reason is because I had to switch the inequality on B, because it has to point to the -6, so I worked off of that sign,
Okay.
all right? Okay, any other questions? Now, solve the system of equations graphically and then algebraically. So, solve this graphically first, then when you're done, solve it algebraically, see that your answers match. By the way, this is a great question to do using substitution and not elimination, okay? Go ahead. You can work with the person sitting next to you if you want, all right? I have a couple of papers to grade from yesterday, so I'm gonna grade some papers while you work on this for a couple minutes. Yeah, we gotta get it algebraically also, right? One more minute and I'll put it up on the board. Okay. Now, hopefully the graph works out that I can fit it cleanly on this. So, the first one, what's really nice about this graph is that everything is, you know what I can do? I'll make this pen smaller, that'll help you. Everything is in y equals 4. So the slope is 4, the y-intercept is -1. So whoever's phone that is can go back. Here's -1. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. Now this is the tough part. I'll make it as clean as I can make it.
Isn't there like a button I can press and it looks like a straight line?
Yeah, right? Wouldn't that be nice? Y equals 4x minus 1. Okay, now, for the next line, y equals -1/2 x plus 8. I touch here at 8. 1, 2, 3, 4, 5, 6, 7, 8. Down 1 over 2. Nice.
Oh,
Found the exact
yeah.
point. That's it. Oh, yeah. Booyah.
I got that intercept.
What are you like Woody Woodpecker? I forgot to mention the slope was -1/2 and the y-intercept was 8. I mentioned it, I didn't write it down. Okay, so the common solution here is the point where x is 2 and y is 7. So that's my solution, 2, 7. Any questions about that? Now that should be a very routine, very straightforward question. I would hope that all of you nailed that very easily. Doing it algebraically is not difficult either. However, we've only done 1 or 2 substitutions so far, so in the beginning they can be a little awkward. Now look, if I said to you that font weighs the same exact thing as Julia, and if I said Julia weighs the same exact thing as Kirsten, what do you know about font and Kirsten? They weigh the same. So I'm saying, look, y is this, and y is also that, so what do you know about these two guys? They're equal to each other. So I can just write 4x minus 1 equals -1/2 x plus 8.
I knew I should have did that.
Add a half x to both sides. And I get 4 and 1/2 x minus 1 equals 8. Add 1 to both sides. 4 and a half x equals 9. I think you see where we're going here. Divide by 4 and a half. 9 divided by 4 and a half, for those who aren't comfortable with it, is 2. You can always use your calculator to do that division. 9 divided by 4.5, and you get 2. Now, I have to go back and get y. To go back and get y, the y is going to equal -1/2 times 2 plus 8. -1/2 times 2, die, is -1 plus 8. Y is 7. So here, I get 2, 7. Here, I get 2, 7. So whether I do it graphically or whether I do it algebraically, I come up with the same solution either way. Any questions? We're good? Yes?
What is the point of doing algebraically if you can do it graphically?
Well, first off, some people in here will prefer algebra because they just see it and they get it quickly. Some people will say, I don't really want to set up a whole graph. Some people will say, nah, I'd rather graph, forget the algebra. And the biggest thing about graphing is when it doesn't meet on an exact point, it can be frustrating. So algebra, like we did one on the homework last night where it didn't work on an exact point. Okay, next up. Graphing 3 inequalities at the same time. I'll give you about 3 minutes to get it done, and then I'll go over it with you. Even 2 minutes to get it done. Yeah, you're just graphing it. That's all you're doing. You're graphing 3 inequalities, and then you're going to look for the area that's triple shaded. 30 seconds. Okay, so now I'm just going to graph all three inequalities at the same time. I'm going to save the first one for last, though. Okay. Y is less than 2. We just said this y1 with 0 slope. We just did one just like that. Is going to go right through 2. It's going to be a broken line. And this time it's less than, so I shade below. Okay. Next, x plus 3y is greater than 0. I'm going to minus the x. And I get 3y is greater than negative x, divide by 3. What's the slope here, guys? What's the slope?
0. Wait, what? Oh, negative 1.
Negative 1/3. What's the y-intercept? 0. So I begin at 0, down 1 over 3, down 1 over 3, down 1 over 3. And is this a broken or a solid line?
Broken.
Broken line it is. And do I shade above or below? Above. Okay. Now I get to the first one. And this has no slope about it at all because it doesn't say y equals. So any x equals line is always a perfectly vertical line. In this case, it goes through 0, so it's actually going to be the y-axis. It's the same exact line, except I'm going to shade to the right. So my solution set is the part right here that's triple shaded. Okay? So this question, what I did with the inequalities today is I tried to throw weird ones at you so that you would see them and be a little more comfortable about them should you see weird ones in the future. Any questions? All right, it's the same thing, simultaneous, simultaneous. And they lead us to the corrections. Thank you so much, Sophie.
I have a question then.
Yes.
Can you use the biggest thing to draw?
Huh?
Can you use the biggest?
The biggest dot?
Yeah, that dot.
Well, not on a graph like this.
I don't know that, but I just did it. You can just draw it really quick.
Oh. Oh, you want to just see how big it is?
Right there. It's there. It's on the paper. Oh, not that big. All right.
Does that work? Beepster.